Guys, it's Mr. Z, and today we're going to continue solving radical equations. Let's go ahead and take a look and practice this essential skill. All right, I got to say it again and again and again. When you're solving each equation, thou must check for extraneous solutions. You are going to need to check. Do not skip this. Let's go ahead and take a look. So in this guy, I see that I have to do my inverse operations, and I always go in the same order as my order of operations. But I have to go in the opposite order because I'm doing the inverses, the opposite. So I'm going to start with addition and subtraction, multiply and divide, exponents, and then parentheses. So I see this guy right here, and I see that the radical is by itself, right? There's no terms on the side of it. There's no terms in the front of it. And I know that when they don't write an index, it is going to be assumed that it's a square root. So what I need to do to both sides is I need to take x minus 4, and then I'm going to take the whole right side, which is going to be the square root of 2x minus 9, and I'm going to raise them both to the second power. All right, this is going to result in x minus 4 squared, which is going to be equal to just the inside. So what I did is I was able to take my radical equation and eliminate the radical. Now some of you might be wondering, well, what the heck do I have to do? I would expand x minus 4 so that it's an x minus 4 times x minus 4, which is going to be equal to 2x minus 9. And the idea here is I need to multiply them. So I'm going to take x minus 4, multiply by x minus 4, and this is going to produce x squared minus 4x minus 4x and positive 16. And if I combine the middle terms, this is going to be equivalent to x squared minus 8x plus 16 equals 2x minus 9. If you're still confused on what to do, remember 0, product, property. Is it equal to 0? Well, not yet. I need to figure out a way. So when I see x squared, I'm going to get everything onto that side. So I'm going to subtract 2x and add 9. This is going to result in x squared minus 10x plus 25 being equal to 0. Boom. Now for my product, right? I need to figure out what the heck it multiplies. So I need to factor x squared minus 10x plus 25. So I'm going to go ahead and set up my area model. I'm going to factor out x squared and 25. Okay, what numbers multiply to be x squared? Well, x times x is x squared. I need to construct a negative 10x. So if I did 5 and 5, that would be 5x and 5x, which would make 10x, but I need it to be negative. So I was able to successfully factor this. This is going to be equivalent to x minus 5 times x minus 5, which is equal to 0. I have written it as a product. And then finally, property, look at each of them. When does x minus 5 equal to 0? Well, when x is equal to 5, and vice versa here. My last thing to do is my check. I'm going to plug in my value for 5. So I need to do 5 minus 4 equals the square root of 2 times 5 minus 9. 1 is equal to the square root of 10 minus 9. 1 is equal to square root of 1. Absolutely. Therefore, my solution is that for this radical equation, x is equal to 5. Let's do another example. All right. Now, even though it's not to the same index, it's to the third. I'm going to start out, and I'm going to raise this to the third power and this guy to the third power. Now this is going to be on the left. It's going to be the same as negative x times negative x times negative x, which is going to be equal to the inside. If I process that on the left, a negative times a negative is going to be positive x squared, which is going to be multiplied by negative x. So this is really just equal to negative x to the third equals x squared minus 12x. Now I want to get everything on the same side because in order to solve this guy, I need to have one side be equal to 0. So I'm going to go ahead and I'm going to do the inverse of negative x to the third. I'm going to add that to both sides. This is going to result in 0, what I wanted, equals x to the third plus x squared minus 12x. Now when I'm doing this guy, I need to factor it. I always like to think about, hey, what do I have to multiply to get x to the third, x squared, and negative 12x? What is a common factor in all of them? Well, x. Now, what multiplies to produce it? Well, x times x squared is x to the third, x times x, and then x times negative 12. So I'm able to factor it or rewrite it as a product times x squared. What type of x? Positive x minus 12. Now, even though it's equal to 0, I still have to continue to factor it. Now, I'm going to ignore that x in the front for right now. And the idea is that I'm just going to simply try to figure out what the heck factors into this. So I go ahead and look at my area model. I know my first term will go in the top left. I know my last term will go in the bottom right. And I have to figure out a way to construct positive x. So I'm going to write x squared, negative 12. Starting with x squared, I know that x times x is the only thing that will construct x squared. Now I need to figure out a way using the factors of negative 12 to get positive x. Positive x. I'm going to use positive 4 and negative 3 because 4x minus 3x is indeed going to be 1x. So I'm able to write it as x plus 4 times x minus 3. Leading me to my property. Hey, x is going to be negative 4, x is going to be 3. I need to check this guy though, so let's go ahead and plug it in. So in my original guy, I have to plug in negative 4 in. So it's going to be negative 4 equals the cube root of negative 4 squared minus 12 times negative 4. Likewise, for part 2, I would have to check the second solution, which would be negative, well, it's 3, equals the cube root of 3 squared minus 12 times 3. When I evaluate the left side of the first one, I get 4 equals the cube root of 16 plus 48, which is 4 equals the cube root of 64, which is definitely equal to 4. So I know that negative 4 is a solution. To verify if 3 is a solution as well, I evaluate negative 3 is equal to the cube root of 3 squared is 9, 12 times 3 is negative 36, and negative 3 is equal to the cube root of 9 minus 36. When I take away 36, I get negative 27, and that indeed is equal to negative 3. So both of these are solutions to my problem. When I have it, I have sufficient proof that in this situation, x is going to be negative 4 or it's 3. The Final guy. How do I do this? Oh my goodness. Well, rewrite it as a radical. This is going to be x to the first power to the cube root minus 4 equals 0. I can further simplify that and leave out the power of 1. I add 4 to both sides, and I get the cube root of x is going to be equal to 4. How do I get rid of that cube root? Well, I'm going to raise each side to the third. This is going to produce x, which is going to be equal to 64. Like my previous situations, I have to do my check. And what I'm going to do is plug in 64 into the cube root and see if it does indeed equal to 0. This is going to be 4 minus 4. And this means that 64 is indeed a solution. All right. So to summarize, there's been 3 problems we did right now. It's just to kind of elaborate that the problem can take multiple turns. I want you to, in all of them, essentially look at it, get rid of the radical, and then do what you got to do to get x by itself. Remember, follow your operations, show your work, and in this section, check, check,